Hi everyone, welcome back to my channel. And today let's practice the hard question, shortest subarray with sum at least k. So we are given an integer array nums and an integer k, and we should return the length of the shortest non-empty subarray of nums with a sum of at least k. If there is no such subarray, then we return -1. So here it gives us the definition of a subarray. So the subarray is a contiguous part of an array. Let's look at example 3 here. So here we have multiple subarrays, like 2 itself is a subarray, or 2 and -1 is also a subarray, or 2 and -1 and 2 is also a subarray. It seems like the question could be solved by the sliding windows. However, it couldn't. Why? Because in sliding window, we can show that whenever our window here increase, for example, increase from these 2 elements to 3 elements, the bigger windows, the sum of the bigger windows is always bigger than the sum of the smaller window here. However, in the question, we have a negative number. So whenever we increase the window size, we cannot assure that the increased window has a bigger sum. So we cannot use the sliding window here. But actually, we can use some variation of the sliding window. Let's look at a more complicated example. Here we are given the array of 2, 3, 4, and also the index of the array here. So in order to calculate the sum of a subarray, for example, we want to have a sum of the subarray, to have another array that is called the prefix sum. Keeps track of all the elements prior to the current index. Index equals to 0. The prefix sum is 0 because there is no element prior to the index 0. And if the index is 1, then the prefix sum is the 2 here. The sum of the prior elements, they are prior to the first the index of the array. Or if we want to have the prefix sum of 4, then we will add 3 and 2, and then we have 5. After we have the prefix sum, it is easy for us to calculate the sum of a subarray in any range. For example, if we want to calculate the subarray in this range from -4 to 6, we can use a prefix sum from the 0 index to index 4, and then we subtract the prior prefix sum. And now this part is the sum of the subarray from index 2 to index 4. The next thing is to figure out the start index and ending index of the subarray. In a brute-force solution, we have a start index from the beginning and the index from the next position. And we can check if 2 minus 0 is it bigger or equals to 8. If it is not, let's check the next element. So that is 5 minus 0. It is also smaller than 8. And then we can check another example. It is 0 and 9. So whether 9 minus 0 bigger or equal to 8. Yeah, it is. So that is one of our potential solution. And after that, so we already have the first solution. Do we have to also check the start index of 0 and comparing to the ending index of 4 to this element? No, we don't, because if there is any elements in the renaming prefix sum, and that is also satisfy the k condition, but the length of the subarray will always bigger than the length of the subarray when the ending index is here, is 3. So if we find out a solution here, then we can stop, and then we can try another start index. So let's move from the 2 here. Let's check 2 and 5. So the difference between 5 and 2 is 3. It's smaller than 8. So that is not a solution. Then 2 and 9 is 7. Is still smaller than 8. So that is also not a solution. And then we can check if this one, 2 and 5 is smaller 8, and then we can check 2 and 11, and that is 9. So we have 11 minus 2 is greater than 8. So that is also one of the possible solutions. We will iterate all of the start index. So from 0, and then 2, and then 5, and then 9, and then 5 again. So for the 5, we'll compare 5 and 11, and 5 and 14. Before 5, when our start index is 9, we compare 9 and 5, and 9 and 11, and 9 and 14. So since the 5 is smaller than 9, here is a redundant work. 5 is smaller than 9. The 5 has the bigger index. It means every element after the 5 that can satisfy the k condition when it pairs with the start of the 3, that is the 9. It can always also works when the start index is 4, so which the value is 5, because the 5 is smaller than 9, and also the 5 has a bigger index, so the length of the subarray will be smaller when the start index of the subarray is 3. So in the prefix sum array, whenever we found an element, here 5 is smaller than its previous elements, it makes the previous work redundant. So if we want to remove the 9. We want to remove the 9 from our prefix index, so we don't count the subarray which starts from 9. So how do we do that? In the brute force observation, we can perceive that first, whenever the start index it pairs with an end index and it is satisfied with the k condition, and then we will want to remove the start index from our next consideration, because if we keep this start index and then we increase our end index, for example, now our ending index is E2, then the length of this subarray will always bigger than the length of this subarray. So I don't want to do the redundant work. So after we have found this pair, then we want to move the start index to the next start index. Besides this, the second observation is that if there are multiple start index and multiple prefix value, if the prefix value, for example here 2, is smaller than its previous prefix sum, then we no longer consider this. We don't want to calculate the subarray when the S1 is the start index. So we have a prefix sum of P1, P2, and P3, and P4. For the first row, it tells us we want to remove the value from the start of the array. And for the second row, it tells us we want to remove the element from the end of the array. So we want to use the deque data structure, which can help us remove elements from both sides of the array. Okay, now let me show you how to use the deque to solve this problem. So in our deque, we want to store the prefix value in the start index. In our deque, so in the deque, every element is a tuple. Besides that, we also want to keep a it means the end index of the subarray. So first, let me put the start index, the P0, that is 0 and 0. And now the end index is also here when I is 0. So the sum of the subarray is 0 minus 0, which is also 0. Is it greater or bigger than 8? No, it is not. So we move our ending index to the next element. Okay, in the next element, the value is 2. And the potential start index in this deque is 0. So that is 2. Is this bigger than 8? This index 1 will become our potential start index of another subarray. So we put it here. We have a prefix 2 of 2, and the index is 1. For the ending index here, and so we have 5 minus 0. It is 5. Is it bigger or equal to 8? No, it is not. So we will move our ending index to the next position and also put the current position, the current index in our deque. It means it can be a start index for the future ending index. So we'll have a 5 and index is 2 here. And now we want to check for the 9, ending index 9, and minus the start index 0. That is 9. Yeah, in this one, it is bigger than 8. So that is our potential solution. We want to have our result is the index of it is 3, ending index, and the start index is a 0, so the length is 3. And since we already find a pairing ending index for this start index, then we want to pop out this element from the deque, because it is the shortest subarray we can find out for the start index of 0. And then we want to check the next start index, which is this one, is the end index 9 minus 2. Is it 7? Is it bigger or equal to 8? No, it isn't. So we stop here. And we want to put the end index to the deque. We have an index value of 9 and the index is 3. Okay, so here I want to classify that whenever we have an end index, the first thing we check is the head of the deque, and then if it satisfies our condition, and then we want to check the next element in the deque. If the element in the deque here doesn't satisfy the condition, then we don't have to look over other start index. The end index should increase to the next position. So we have the value of 5 in the start index is 2. Now it's 2. It is 3. Is this bigger or equals to 8? No, it isn't. So put this 5 into our start index. So it is 5 and the value is 5 and the index is 4. But wait, from our observation we know that if we find out a start index that is in later index but its value is smaller than his previous index, then we want to pop out the previous start index. We will pop out this one and also check if 5 is smaller than 5. No, they are the same, but when we encounter the same value, we have to consider the index. Since index 4 is bigger than index 2, it means the start index of 4 will produce a shorter subarray. So we also want to pop out this from the deque. Then we check if the 5 is smaller than this one too. No, it is not. So we stop here. Next, we want to move our end index to this position, 11. This value 11. So the value is 11, and now our start value is 2. Minus 2 is 9. Is it greater or equal to 8? Yeah, it is. So here is another solution. And the index of 11 is 5. And the index of start index is 1 here. That is 4. Okay, so it is bigger than 3. So we just remain the 3 here and we won't update this one. Since we already find out the pairing and index of this start index, we have to pop out this start index from our deque. And we also like to move this value into our potential start index. So it's 11 and index 5. And now let's check. The 11 is greater than this 5, so we don't pop out the 5 and 4 from the deque. And next, we'll move our ending index to the 14. So let's check. The 14 minus the start value now is 5. Is 9, so it is bigger than the 8. So that is another potential solution. So let me write it here. The index of 14 is 6. And the index of our start index is 4. So that is 2. And 2 is smaller than the 3. So now our answer is 2. Also, we have to pop out the element from our deque and put the value here is our potential start index, and then move our end index to the next position. We can stop here because we already reached the end of the array, and there is no end index for us to calculate the subarray. Okay, now let's start coding. So first, we would like to make the prefix sum array. So it's called prefix sum. And first, let's initialize it as a 0 in every element in the prefix sum. So, and be careful here, we need to have one more length more than the nums. So for every element in the prefix sum, it is the previous element is I-1 plus the nums of so for every element in the prefix sum, it should be its previous element and plus the elements in the previous position in nums. After that, now we can start to iterate the nums. So for it is end index. And before that, we also like to have a deque to store all the potential start index. So here I specify that what I want to store in the deque is all the potential start index of the subarray. So first, here we want to check two conditions. So first is check the first element in the deque, and then we want to check the last element in the deque. So here we want to know whether the current start index and the current end index here can produce a subarray which the sum of the subarray is greater or equal to k. If that is true, then we will like to update the results variable. Though I'm not with the care now, I will do it later. And then we also like to pop out the start index from the deque because it's already used, and that is the possible shortest subarray. This start index can be used. So now let's declare the rest variable. So let's give it infinity initial number. Okay, so here is the start index, and we want to know the value in the start index. if that is true, we want to pop out the element. And also we like to update our result variable. And then we want to put the end index in our deque to be the next potential start index. But before that, we have to check whether there are some elements in the deque as the end of the deque, and the value in the prefix sum is greater than the current value in the prefix sum, which is the value in the end index position. So if there exists such value, or then we also want to pop out that value from our deque. So if that is smaller or equals to the last element in the deque, then we want to pop out the element. And after we pop out, we will append the end index as the deque. Okay, after iterating all of the end index in the prefix sum, then we can now return the results. However, the results maybe is initial number, which is infinity, because no such subarray exists. And in the description it says if there is no subarray, then we want to return -1. So if the result is a float infinity, then we want to return -1. Okay, now let's check the pass.